Alright, welcome back to our derivation. So using the first equation of motion, so V equals to ut uat, where V is 0 and Vy equals u sin theta. So we have so we can say that O equals to u sin theta minus g in bracket of t. Alright, so we have minus u sin theta equals to minus gt. So from here we have minus is common, we cancel the minus on the both sides. So t will give us minus u sin theta over minus g, cancel out this minus. So finally, time taken of a projectile will give us u sin theta all over g. So here is the time taken of a projectile. Alright, so time of flight of a projectile is given as, okay, from the diagram we have, we know that time of flight is the total time taken required for an object to reach its projection plane. So we have 2t, where our t is u sin theta over g. So we have, when we multiply, it finally gives us 2u sin theta over g. The next one is the maximum height of a projectile. So we are using second equation of motion, which says v squared equals to u squared plus 2ax. So v becomes 0 meter per second. So acceleration a will give us minus g. So x becomes height. So this is motion under the influence of gravity. So from here we have O squared equals to u sin theta all squared. That's a vertical component. So we have minus 2gh. That is, this will give us minus u squared. If you expand this, you have u squared sin squared theta. That's the expansion of this. You have sin squared theta equals to minus 2gh. So I'm looking for the maximum height, of which I'll be having minus u squared sin squared theta over minus 2gh. Sorry, minus 2g. Minus is common, cancel it out. So we have h as the final note of the maximum height equation, u squared sin squared theta over 2g. This is the maximum height of the projectile. Our range is called the horizontal distance of the projectile. So from this diagram, the range value starts from this x naught to where we are having x here. So range will give us the horizontal component of the projectile times the time of flight. That is, range r will be equals to vx times t. Vx times t, that's the range we'll be having. So from there we know where vx is equals to u cos theta and t is equals to 2u sin theta over g. That's the maximum height. So we can find the equation by saying range is equals to u cos theta times 2u sin theta over g. So if you multiply, you have u squared over g times 2 sin theta cos theta. So under the trigonometry identity, we know that 2 sin theta cos theta will be equals to sin 2 theta. So we can just have our range equation to be